Okay, team, hey, here we go. We're in 9.2, using lines of fit to represent data. We have a Desmos assignment to help with this, and the first thing it's going to ask you to do is to take your line. You got this little blue line you can move, and you're going to do your best to represent the data, which means I'm basically just going to make sure my line goes through the points as best I can and in the right direction of the data. And these are almost perfectly linear. Like, I can see really only 1 point is off my line right now. So this is a pretty good line of fit. That's not always the case though, team. Sometimes you have these data points all over the place. But you can still use a line of fit to represent that data, so long as the points seem to follow a linear trend. To write an equation for your line of fit, we are going to use our good friend slope-intercept form, y equals mx plus b. So quick reminder about that. The m is your slope. Your b is your y-intercept. We need to find both of those in order to write the equation. So finding the slope here, slope is the rise over the run. Or we've also seen this slope formula, y2 minus y1 over x2 minus x1. And I'm actually going to kind of do this almost like mental math, actually. I'll show you how I can do that to find the slope pretty quickly. But basically, I'm subtracting the y values up top. I'm subtracting the x values down below. So in this case, my y values are 6,000 and 70,000. So I'm just going to do that in my head real quick. Actually, maybe I don't need to do that in my head. 70,000 minus 6,000. And that is 64,000. So I got 64,000. I'm subtracting the y values. So that's the top. Below, the bottom part, the run, is going to be subtracting the x values, which I have 0 and 450. Well, 450 minus 0 is just 450. There's my slope, and it turns out in Desmos it will turn that into a decimal for us, or reduce the fraction, which is helpful. The y-intercept, this is just the start of your line. Or you can think of it as the place where your line crosses the y-axis. In this case, it's 6,000. So my y-intercept is that start 6,000. Now I can write my equation. Slope goes in the m spot. So I'm going to change m to 6,000. The y-intercept, that goes in the b spot. And I'm just using, the good old slope-intercept form. So that's 6,000. There's my equation. Now, Desmos seems to be doing mostly right when we graph our line. So I'm gonna click graph my line. Oh, looks like I made a mistake. I put the y-intercept where the slope is supposed to go, 142.2. Let's try that. So it's telling me I need to adjust my line, except for I can see that I don't actually need to, because this line turned orange. So I know I'm actually good, which is a tiny bit frustrating that that's not working perfectly, but oh well. Anyway, that is how I am going to write an equation. I'm going to find a slope, I'm going to find a y-intercept, I'm going to type an equation, and then the graphing part works, but this part may not work, just so you know. All right, next slide, we're going to interpret the context now. So now I need to pay attention to what my x-axis is, what my y-axis is, to interpret what this data actually means. So it looks like I'm painting fences. It makes sense that the longer your fence is, the more expensive it is. That makes sense. So in the context, the y-intercept, so the start of my graph, what does that actually mean? Well, it just means the starting cost to paint the fence is $6,000. So there's my starting cost. That's how I'm going to interpret the y-intercept. The slope, that just means the longer the bridge is, the more expensive it costs to paint it. And I can be a little bit more specific because I know the slope. I can say the cost of painting the fence, increases $142.2 per foot. And the cost of a 600-foot bridge, well, let's come down here and we can look at our graph here. A 600-foot bridge. It looks like I'm not quite going to make it. It'd be right around here. I could guess. It's going to be somewhere around 90,000, probably a little bit over it. Here's the trick for that. I'm going to use my equation. I'm going to say y equals 142.2. Instead of x, I'm going to now make a substitution of 600 feet. That's what I'm told. Plus 6,000. So that's my trick I'm going to use right here. I'm going to use this equation. And I'm actually going to go to a calculator real quick and do that for us. 142.2 times 600 plus 6,000 equals 91,320. So this equals $91,320. That's how much it would cost to paint a 600-foot bridge. Okay. A few things I should mention while we're here, guys, is a line of fit. Your line might be a little different than my line because it's an approximation. Like I could have, maybe my line looks something like that. Is that line worse than the line that I originally came up with? Probably not. Our lines should be close, but what I'm saying is it's okay if your numbers are a little bit different than mine. That's okay. Our lines of fit should all be pretty close, but that they're not necessarily going to be exactly the same. So keep that in mind as you do your Desmos assignment, and that is using lines of fit to represent data. Thanks, guys.